Hello, welcome to this video. This video is about the basic understanding of NONC switches, series parallel circuits, some relay logic, latching and interlocking, unlatching. So we'll understand how these things are done. Before learning to PLC, before coming to PLC, we'll see how these things can be controlled and what are the basic fundamentals of NONC. So initially I'm going to make a series AND gate, alright. So for that I'm going to use two switches. Okay, I have to give a name here, so I'm naming at A or B, right? So you can assume these names. So this is my second switch, I'm naming it as B. Now this switch is push button normally open, alright. So this is having a spring loaded button in reality, but this is a symbol for that. If you push that, it will make a contact. If you release it by spring action, it will goes back to this initial position. So I'm having these two push buttons. Now let's take output component. So this is going to be two input AND gate. It's a realization of AND gate in electrical control. So I'm naming it as X. So we can assume that this indicator runs on line and neutral. So we need some power sources. So let's have L1 here and a neutral here. Now to complete the circuit, to actually actuate this actuator or indicator, what does it require? A line and a neutral, a high potential and low potential. So generally we connect low potential directly to one end of this indicator, and this high potential comes from the switches. So how does it come? So we have to connect something like this. So line is connected to one end of switch, second end goes to this end, and this end goes to this end. So now it's very common to understand that if I press this one, then I need to press this one as well to pass the line from here to the indicator. So let's check that. Let's check that. For that I have to start the simulation. Now this is my first button, and if you can see this this line has changed its color. This is green. So this is green is up to this point, neutral is coming here. So I have to transfer this line to this X terminal. So for that I have to press this first. Okay, so let me just press it. So now this signal is going here. Now if I press this one, light will be on. So that is a realization of AND gate, in which if both inputs are high, output is high. If any of the input is high and the other one is off, the output will not be on. If both are off, output will be off. So that's what happens in AND gate, and that's what we call it a series circuit. So that was a series circuit. Let me write it here. Oops. Alright, so next we are going to do is what we call parallel circuit. Okay, in parallel, which is actually a representation of OR gate, in which if we press any of the switch, output should be on. Okay, parallel circuit. So in that case, what do I need is, if I have to press any of the switch, output should be on. If I press both, then again output should be on. So for that I have to connect this in parallel. Okay, it has to be connected like this. Now these inputs are in parallel. So if I press any of the input, line will pass and it will go to the X indicator, and this will turn on the light. So that says if any of the input or if both the inputs are on, light is on. If only one is on, light is off. Okay, so this was series and parallel circuits. Then this is a realization of OR gate. Let me write it here. If I have to write a boolean of that, I can write like this: a plus b is equal to x. This is the boolean of OR gate, and for AND gate it is a. Okay, let me write AND gate. This is a dot b equal to x. So this dot represent here, this is an AND gate. This plus represent it's an OR gate. So there's one more gate which comes under the category of primary gates. These are the primary gates. AND gate is a primary, OR is primary. Third one is NOT gate. Okay, so let me write here. In that case, this is the realization. Now it's actually a bar is equal to a. I cannot write bar in my keyboard, there's no bar here, so I'm taking this symbol as a bar. A bar is equal to a. Bar means inverse. A inverse is equal to a. So what does that mean? Suppose this is my input. Okay, and let me rename it as a. for that I will be using another switch which is called normally close. Right, this is a normally closed switch. This one is normally open. In normally closed, it will always pass the circuit even if you're not pressing this one. Okay, it's the opposite of that one. It's normally open. So if I press this button, if I actuate this, the output will be off. If I release this, this will be on. So that is what NOT gate does. If you provide signal to NOT gate, if the input is high, output is low. So if the input is high, this is high input for A, output is low, output is off. But if the input is low, in NOT gate, output is high. So the input is low here. Now there is no input. I'm not pressing it. So the output is high. If I press it, this main input is high. So the output is low. So that is the basic representation of NOT gate. This is an NC switch, which is actuating this indicator. All right. So these were the three primary gates and its realization in electrical control, electrical circuits. So the next we are going to do is yeah, we have to do the latching, but before latching I just want to share that we also have a toggle switch. These are the toggle switch which are typically not having, which are actually not having a spring. They maintain a situation, maintain the position once they are actuated. Are generally used in our household material. In household actuation we use toggle switch. For bell switch they are typically push buttons, but when you turn off a light in your room, so that is a toggle switch. So when you press this button it will remain here, and you press this one, this will turn on. So there is no spring here, otherwise it's again normally open, similar as this one but without a spring. They retain this position. So now let's move on to latching, the principle of latching. Now suppose, what is the latching? Now suppose if I want that if I press this button here and if I release this, this should remain on. It should not get off. It should remain on just by the pulse input. That is called latching. So how to do that? Let's see a latching circuit now. So in latching circuit we need a relay, right? So I need some more space here, so let me just increase the size of this sheet. Okay, so for the time I'm copying the circuit, so just to save my time let me paste here. Alright, so we are going to do latching and so in latching and unlatching I've taken this line 1 and neutral, and this is my contact. So what I want is that if I press the switch and if I release this, this should remain on, this should not get off. So how to make that circuit? So to make that we need an additional component which is called relay. And if you understand relay is an electromechanical switch in which, you know, we have a coil, this is a coil, and we have some contacts. Alright, so let me tell you what is this coil and contact is. So initially, if you understand a coil, it's basically a wire wounded in a round shape. So if you provide a signal to this coil, it will make some electromagnet. It will have electromagnet. It will become electromagnet. Right? It will start having a magnetic action. So due to that magnetic action, it will attract a contact. You know, it will attract and repel a contact. So that contact is generally look like this. So let me show you here. So this is a symbol of normally open contact. In relay we have normally open and normally close. So if you look at some figure in some diagram, let me show you how. If you Google that relay, just let's put a relay here. So I'm going to show you how actually relay looks like. So till that page that loads, we have to connect one part of the contact like this. Okay, so now we have three terminals. This is 1, 2 and 3. So this terminal is called common. Alright, and this terminal is called NO, normally open. This is normally open, and this is NC, normally closed. Okay, so I get some problem in my anyways, so till that page load I'll explain you. So we have to tag this contact to relay to, because this is a software, we have to do such kind of formalities. So I'm tagging this to relay, this one as well. Now it means that this contact is a contact of this relay. This addressing should be same. So what will happen if I turn on this relay using this switch? This contact will be closed. You know, this is a common and this is NO. This will get closed and this will get open. So this open and close in practical sense is done by the magnetic action of this relay. Okay, so I was talking about the latching. So I'm going to give this line neutral. Oh, sorry, this supply I'm going to give it a live. This is common. All right. So let me just write here once. This is common. This is NO. This one is NC. Okay, so this common is connected to line, and this NO is connected to a terminal which you want to latch. Sorry, it is connected like this. Okay, so I'm connecting this NO terminal to the switch. Okay, so NC, this is left alone. I don't want this NC here. So this connection is called latching. Okay, so what happened here is when you press this switch. Now I'm just pressing it. This relay is on because this is giving supply of line and neutral here. And due to this relay, this contact is closed. All right. And when this contact is closed, now we have two supply. One is coming from here, another one is coming from here. Okay, it is going to this indicator relay. So we have one supply from here, one from here. So even if I release this one, this will remain latched because of this auxiliary supply. So this NO contact is an auxiliary contact which is turning on a relay and providing some auxiliary supply of line. Okay, so let me explain again. So this is my switch, this is my relay, this is the NO contact. In NO contact is common is not connected to NO when relay is off. That's why it's called normally open. Normally means when relay is off. So when relay is off, common and this NO, there's a strip between that which is not connected. Okay, when relay is on, this strip get connected. So when relay is off, this get disconnected because of spring action. So because of this connection, relay is latched like this. This is the latching. And this NC contact is generally used to indicate when relay is off. Okay, so how to do that? So in that case, let me just give a color to this indicator. I'm giving it a green color. Let me have one more. So to that, I'm giving a red color. Okay. So because to indicate something when it is off, we usually have a red color LED. Okay. So connecting this over here. So now you see, when relay is off, this is red. This indicator is on because common is connected to NC because it says normally close. Normally means when relay is off, close means this contact is closed. So the when relay turns on, this get closed and this gets open. So that's why this is closed, so this is latched, green is on. This is open, that's why red is off. So that's what happened in a relay. When one thing is on, another gets off. So these two works alternatively. When common is connected to NO only when relay is on, common is connected to NC when relay is off. So how to turn off the relay? Now that's the question. To what we call unlatching. To turn off the latching, we call it unlatching. So how to unlatch this? We have to use another switch here. We'll be using this push button normally close. Let me write this. I can write stop. Okay, so I'll remove this line here. I'll put this in series and connect something like this. Now you know that this is already closed. This is like a NOT key. Okay, so this again it's a latching. It is latched because this is already closed. So when you push this button, what will happen? Relay will be off because there will be no supply. When relay is off, this contact will be off, so latching will be off like this. I'll do again. This is the latching and we have to break this circuit, so this is unlatching, latching, unlatching, latching, and this is unlatching. So that's the latching and unlatching of simple indicator. Similar way you can also latch and unlatch a motor, right? A DC motor or a AC motor. So let's try for an AC motor. So we are having an output component of AC motor like this. Okay, so let me just write a name. So if you want to latch this motor, you have two options. Either you can connect this motor in parallel to this circuit. Let me show you how. Control H. So I can connect this motor like this. I can connect this in parallel to my relay or in parallel to LED. It's one of the same thing. So when I turn this on, so when I latch this, motor has been latched, motor is on. Okay, when I do this, this is unlatched. So this is latched and unlatched. So that's how single phase motor can be latched using simple relay and two push buttons and using some auxiliary contacts. And you can, instead of this switch, you can also have, you can have a sensor, you can have limit switch, you can have any source of input. You just need to fire this relay, you just need to actuate this relay and use this contact to have a latching. So in this way we can do the latching. Now what about the three-phase motor? Suppose you are having a three-phase motor, how will you latch that? Okay, now that's the question. So for that we use contactors. Alright, so okay, I'll come to this three-phase motor later. Let me show you another principle of relay, another main function of relay, which is called interlocking. Okay, I'm going to write this here. Let me just copy this one. Okay, I don't have much space. Now we are going to do interlocking. What is that interlocking? Let me just explain you. Hold on. So I don't need to have this here. This is how to spell interlocking. So this is, oh, now what is interlocking? Interlocking means when you don't want two motors to be on simultaneously. When you have a situation in any process, like you don't want two things to be on simultaneously, we interlock that. We interlock a circuit. So it means that if I'm turning on this circuit, this will latch this motor. So I'm not pressing the stop button, I just turned on this one as well. Then what will happen? It will latch this one and it will unlatch this one. So it will not let both circuits to be on. It will unlatch this automatically. But how this will work? So let's see that. So for that you just need to have a good understanding of NO and NC. So just focus what I'm doing. So let's remove this circuit for a minute. Okay, let it be here. So now first of all let's remove the stop button. We do not require a stop button. Okay, remove the stop from here as well. Now we know that if this relay is on, okay, to turn it off we have to break the latching, but turning off of this relay should be done by the actuation of this relay. Okay, so okay, let me do one thing. Let me just differentiate this one, otherwise it will be conflicting. I'm naming it as relay 2, relay 2 here, and relay 2 here, and this is also relay 2. So I need to have two relays for interlocking. This is the first one and this is the relay connection. This is the second relay, second motor, second indicator, and these are the extra buttons. So what I need to do is I'll take an NC contact. Let me take a contact from here, this contact, and let me name it as relay 1, or the only relay part. So I'll connect this terminal over here, and this will go like this, and this will go like this. So what is happening here? Similar way I'll do for the relay 2. Okay, let me have some. So now see what's happening. Right now both relays are off. When this relay is off, this NC contact is closed. We have understood that. When this relay is off, this NC contact is closed, and this is closed because this relay is off. So when I latch the first relay like this, what happened? This relay is latched. Why? Because this is already closed, so this is giving an auxiliary supply, and this relay is on. And when this relay is on, look at the auxiliary contact it has. This contact is open because this was NC, so this light is off. This contact is open, okay, because this is NC again. So I have one contact which is closed of this relay and two contacts are open. So what will happen if I press this one? Now let's see. When I press this button, this relay will be on, and due to its contacts this will be open because this is NC of this. So when this is open, it is breaking a supply of parallel loop, this parallel. So this will get off, alright, and due to this relay, this is NO, this will get closed and this will get open. So see what's happening. Okay, because this get open, this gets off and this gets off. So it is actually doing the job of that NC contact, NC switch which we have taken here, but we have to take this NC here, not here, because otherwise you cannot turn on this relay. There will be a problem. Okay, so that we will understand in PLCs why we have took here instead of here. Okay, but this is what a mandatory place to place this relay. So I'll go back here now. This is on, so this is open. Okay, this is latched because this is closed because this is off. So when I press this switch, now again this will get on and this will get open. So this motor will be unlatched. See, similarly for that again. So this thing is called interlocking. At one moment both motor cannot be on, both the motors cannot be on. This is called interlocking. If one is on, other will be off because this circuit is interlocked with this circuit and this circuit is interlocked with the first circuit. Both are interlocked. So this is a good concept of relays. So I was talking about three-phase motor. Now let's do this thing for three-phase motor. First of all, let's do the latching. Then we'll be doing the interlocking. So the latching, I'm taking the circuit here. Let's name it as latching. Now this is a three-phase, so it requires power sources of L1, L2 and L3. So these L1, L2, L3 will go here. And to connect this line 1, line 2 and line 3 to motor, we need 3 more NO contacts of this coil. Alright. Now this must be noted that if you are connecting 3-phase motor, alright, you will never use a relay. We use another device which is called contactor. Alright. So actually both relays or contactor works on same principle, but they are named differently because contactor has typically used for 3-phase supplies. Right, when you need to provide 3-phase supply directly to some device, so we use a device called contactor. It has same principle. It has NO, it has NC, it has a coil, but it's having a heavy rating coil, typically 30 amperes, 50 amperes or more than that. Relay are coming in the range of 10 amperes, 5 amperes, maybe up to 15 amperes, but contactor are generally 30 amperes or more. So we use a contactor, and it is same as relay, so don't get confused. So now contactor, for contactor, this was the latching. Let me just move this one. To unlatch that, we have to take a switch again, just like we did for relay. So there comes your NC contact, and this is connected here, this will be here. Now how to connect this? We need some more contacts of contactor, so I can copy paste this one. So this is the first contact which will connect your line 1 to the first terminal of motor. Okay, now here comes the other one. This will connect line 2 to the middle of motor. This is a big word. Then comes contactor 3, not contactor 3 but the contact 3. So this is how we have to connect motor to a contactor. These are the contacts. Okay, so when you turn on this contactor, you see these contacts are latched. Now why these are latched? Because contactor is latched. So if the contactor is latched, all the contacts will be latched simultaneously. This is one of the NO contact, this is the other 3 NO contacts. So motor is running and motor is stopped. Running, stopped. So this is the latching, simple latching. Just we have more number of contacts in contactor. Okay, now we have to do interlocking of 2 3-phase motors, quite similar to the one which we have made for single phase. So again I'm going to copy this one. I hope you understand the concepts of interlocks, so you can immediately understand how to do this interlocking in the circuit. So I'm naming it as contactor 2, just so that it should not conflict. Contactor 2 here, contactor 2 here, this one. We have to individually name all these as connector 2. So I think most of the tasks has been done. Now we don't have to have this stop button. Instead we need an NC contact of contactor. So I need this one. I'll place it just like we did in relay. I'll place it like this. I'll place this over here. This will be connected like this. So contactor to NC will go to the top circuit and will be connected like this. Okay, so I think the circuit is done now. Let's see. Same thing. This is going to latch the first motor because first contactor is latched. This will latch the second one, and first one will be released. Same as what was happening in this circuit. Alright. So in here we have just single phase motor, so we have connected in parallel. Here it's 3-phase motor. Oops, why do I have connected this? I don't need this here. Sorry. Here it's 3-phase motor, so we have to connect like this because 3-phase require 3 contacts, so L1, L2, L3. That's how it is being done. Okay, so from this circuit I'm going to modify this circuit in a way that if I press this button, motor should run in one direction. If I press this button, this motor should run in reverse direction. Now I'm controlling single motor with 2 contactors. I do not require this. Okay, so how to change the direction? This is called changing the direction of motor using single circuit. I mean using 2 push buttons. If one is pressed, it will be forward. If another is pressed, it is reversed. So how to go for that? How to do that? So I'm going to rename the circuit as AC motor direction control. Alright, so okay, now let me just have more space here. Now we need 3 more contacts for contactor 2. Okay, so I can name it as connector 2. Now you must be knowing that how to change the speed of 3-phase motor. It changes when you change the polarity of any 2 poles, any 2 terminals. Suppose if L1 is coming here, L2 is coming here. If I shuffle this, if L2 goes here and L1 goes here, it will change the speed. So that's what we're gonna do using this contactor terminals. L1 will be connected to this terminal like this, and L1 will go directly to there. So I'm going to shuffle L2 and L3. Alright, so to make this more clear, let me connect it in a way so that you can understand. Right, so L1 is connected like this. Now L2 should go to this terminal now. So I'm going to connect. Okay, let me just remove these names, but it's getting so messed up otherwise. Let me just give me a second. So this is connector 2. Which one is left? Anyways, I think this one is left. Okay, so now this is I'm connecting this to the second terminal. So L2 is already going there, so I want to take L3 here, so I'll connect this one to L3. Okay, similarly this one will be connected to L3 here, and this will be connected to L2. So I've done the shuffling. So just see what's working now. Now L1 is coming to these points, L2 is coming to this point and to the third point. So if this is on, this will go, L2 will go here. If this is on, L2 will go to third point. Similarly L3 here and L3 to here. So you can see that this is one direction anti-clockwise, and this is other direction clockwise. You can see the direction from this symbol. So that's how we change the direction of 3-phase AC motor using these connections. It's quite easy. That was the project which I did. I have made a video in which we were doing this direction control using 2 limit switches. So this is how it can be done. So similarly we can make it for DC motor. In DC motor we worked on 0 volt and 24 volt. I don't have a DC motor in my software, so I cannot show you, can explain you the proper simulation. But in case you want for DC motor, you can send me an email or you can write a post, comment below this video. I can send you the same tutorial. It cannot animate, but I can show you how does it work for DC motor as well. That's the same principle of relays. We do not require contactors for DC motor. So that was the video was about basic concepts of NO, NC, contactor, relays, and series parallel. So I'll review again. This is a series circuit in which we have 2 input AND gate to actuate the output. This was the parallel to actuate something in parallel. This is the NC NOT gate, and then we did latching, then we did interlocking. Similarly, we did latching and interlocking for 3-phase AC motor. Then we did direction control. So that was all about basic industrial control. I hope this lesson will make sense to your PLC further lessons. So this was the lesson which I recommend. You should see that. You should learn from this some NO and NC, so that you may make PLC projects very easily, PLC circuits, because this is the base. This is the base level we should know about it. So thank you so much.